Hi guys, welcome to your notes on converting between units. So today we're going to look at something called the factor label method. I'm going to reference the logic behind this and how you can convert and how it makes sense. But for now, since we're running out of time this school year, I really want to make sure that you're solid on converting units through the factor label method. So let's take a look at our first example. If we want to convert 53.9 inches to centimeters, the first thing that we need to do is we need to know what our conversion factor is. So we have for every 1 inch equals 2.54 centimeters. So I'm going to set up what we can call train tracks. You can see these here in brown. And I start by putting my known value, 53.9 inches, here. Now, I'm trying to figure out how many centimeters are in 53.9 inches. So what I need to do is manipulate this conversion factor so that the 1 inch is in the denominator. Why? Well, what's going to happen is my inches will cancel. So I manipulate it, 1 inch goes in the denominator and 2.54 centimeters goes in the numerator. Now I can convert by taking 53.9 inches, multiplying it by 2.54 centimeters, dividing by 1, and I get 139.06 centimeters. That's my conversion factor. This piece right here, my answer, my conversion is right here. All right, so that's called the factor label method. And if you think about it, if one inch is larger than 1 centimeter, so in 1 inch there's 2.54 centimeters. So if I have 53.9 inches, I need to multiply by centimeters to figure out that there's going to be more centimeters than there would be inches. All right, let's take a look at the next one. Now the next one, we can use these unit conversions to convert multiple units. Here I have 26.3 miles to centimeters. So again, here are our conversion factors. For every 1 mile, there's 5,280 feet. For 12 inches is 1 foot. 2.54 centimeters, there's 1 inch. So our next step, we set up our, I call these train tracks, and we start with our known value, 26.3 miles, and we want our miles to cancel. So I'm going to find the conversion factor that has miles in it, and I'm going to place it in the denominator. The numerator is how many feet. Now I'm working in feet. So I want feet to cancel, so I find my conversion factor with feet, and I put that in the denominator. Feet cancel. Now I'm working in inches. 12 inches is 1 foot. Now I find my other conversion factor. 1 inch is 2.54 centimeters. So now my inches cancel, and I'm left with centimeters. Now I'm ready to multiply. So I take 26.3 times 5,280 times 12 times 2.54, and that's going to give me an answer in centimeters. Divide that by 1, and I get this number right here. Let's see here. That is 4,232,574.7 centimeters. Now, in science, we tend not to write large numbers like this because of the possibility for error. So we're going to convert that to scientific notation. This is a large number, so I know that I'm going to have a positive exponent, and I'm going to move the decimal place until I have till I have a number between 1 and 9. So 4.23 times 10 to the 6th centimeters. All right, another example, we've been doing length. We can also use unit conversions for mass. So I have 255 grams, and I'm converting that to pounds. So this is pretty heavy. Remember that 5 grams is the mass of a nickel. So if you can visualize that nickel in your hand, 255 grams is going to be really, really heavy. Here's our conversion factor. So I start with my known, 255 grams. Now I want grams to cancel, so I'm going to put grams in the denominator. And now all I have to do is take 255 times 1 divided by 453.6, and I get 0.562 pounds. The key thing to remember here is in your calculator, 200, use your parentheses, okay, to make sure that you keep your order of operations straight. Let's look at some more examples I have for you. If we look at number 4, now we have a rate. Instead of an amount, we have a rate, and we want to convert that. We have 60 miles per hour, and we want to convert to meters per second. So again, step 1, etch out my train tracks in brown, and I have all of my conversion factors here. So I start with the known, that's 60 miles per 1 hour. When you see in the denominator here, hour, you add the 1 there. All right, now we want miles to cancel, so I find the unit conversion with miles, and I put miles in the denominator. They cancel. Now I'm in feet. I find the unit conversion with feet. Feet cancel. Now I'm working in inches. I want inches to cancel. Then I'm working in centimeters. So I look for centimeters. I have 100 centimeters in 1 meter. That cancels. Now I'm working in meters. And that's exactly what we want. But now I have to figure out seconds, and I'm in hours. So hours is going to have to go in the numerator so they cancel, because this hours is in the denominator. So I know that 1 hour is 60 minutes. I have that here. And last, I know that for every 1 minute, there's 60 seconds. And I should end up with seconds in the denominator, meters in the numerator. So I do 60 times 5,280 times 12 times 2.54 times 1. Divide that by 100, divide that by 60, and we get 26.8 meters per second. That one's the sort of challenge problem there. The last problem is kind of funky in that I have 1 cubic inch to 1 cubic centimeter. So we're working in volume. What I know is 1 inch equals 2.54 centimeters. So what we're going to do, first we set up 1 inch equals 2.54 centimeters over 1 inch. That way inches cancel. The problem is I have this cubed here. So I also need to cube my unit conversions. So I have 1 times 2.54 cubed equals 16.4 cubic centimeters. All right, so some key things to remember for unit conversions. Number 1, set up your train tracks. They help you stay organized. Number 2, start with your known. Number 3, you're going to use the unit conversions. Number 4, you're going to make units cancel. Pretty easy. So this is how you do your unit conversions. The real challenging ones are when you have rates and you're doing multiple conversions. So the key here is keeping all of your unit conversions straight and checking them off as you go. And always check to make sure that your units cancel. Sometimes it's even easier to circle your answers and make sure they match what you're trying to find. All right, so that's unit conversion. And we didn't focus much on the logic behind the why in this. Right now, I just want you to get the feel for how to convert in units. And where we're going with this is we're going to apply this to measuring molecules and atoms. So our numbers will get more complicated as we begin to look at something called the mole. And that's coming within the next couple weeks. All right, guys, have a great day. And your notes are complete. You're going to have to do a lot of practice on this one.